A lot of people ask me what do I do when my phone gets water damaged. My suggestion is always to open up the phone and dry it out as soon as possible. Otherwise, you're gonna end up with the phone like this one. This is a Samsung S10 and it's full of corrosion all over the motherboard. This happens from the impurities in the water that get left behind, and the electricity triggers a chemical reaction that causes corrosion, which kills the motherboard. In this case, you can see the corrosion is pretty bad all over the motherboard. So we gotta figure out what is causing the phone not to turn on, fix that so we can get this phone to turn on. It's very advanced, and you do want to take it to reputable shops, look up their Google reviews, and see if they specialize in water damage data recovery. We do offer mailing service for anyone in the country or outside of the country. So reach out to me through my website. I will link it down below. But for now, let's go ahead and get started with this water damage repair for data recovery. So the first thing we want to do is do a visual inspection of the condition of the motherboard. You can see how all this white crud is all over the motherboard. Let me turn on my polarizer light. Maybe this will make it a little clearer on what happens with water damage. So we got to fix any circuits critical for the phone to boot up, and you can see this corrosion is everywhere. One of my first things I like to do is clean the corrosion, because that surface layer of corrosion is not good. So what I do is I'll just soak the motherboard, especially this one is like corroded everywhere. So this is not going to fix the phone, but it will at least get rid of some of this nasty corrosion that's on the surface. So I'm using isopropyl alcohol and a toothbrush. Just kind of scrub away any cosmetic level stuff. So just soak it. And you could do this if you know how to safely open your phone and not break the motherboard physically. You could also do this after it gets water damaged. Samsungs are really easy to open compared to iPhones. iPhones, they put special screws that require a special toolkit. I noticed a lot of end users know how to open their own Samsung pretty easily. Although just be careful, the S10s are really common to snap here because there's some hidden screws that you don't notice. But assuming you don't break it, if you break it, we can still get your data. It's just going to be probably twice as much as a normal data recovery price. All right, so I got rid of most of it. Now keep in mind, there's a ton of circuits on this motherboard that are hidden under these metal shields that do require soldering. You can't just peel them off. And if you try, you're going to cause more damage than was necessary. All right, so I got some main corrosion kind of cleaned up. So now when you look at it, it's not as bright. It doesn't have all that bright stuff like this. This is kind of burnt into the shield, so to speak, whereas this other stuff is not, or it brushes away. I'll take a look. Now I am using a special polarizer light for my scope that allows me to do this and then turn it back to normal. It's a very handy tool. Now it is like $150 or so compared to a normal $30 light. But we do data recovery, and it's kind of one of the price of doing this type of work. You got to pay for good tools. Some good tools are pretty expensive. All right, so we got rid of most of that. So there's a few first ways to start. We can start by checking for shorts. So first this is the battery connector. And what I do is inspect it, and I can see there's some burnt corrosion here. And the one thing to keep in mind is corrosion tends to happen where there's electricity flowing. So like the battery connector, there's constant power from the battery being fed into the board to the battery connector. So that you're going to have high levels of corrosion there. So first we're going to check is the power supply. This is like a really good indicator as the kind of starting point on what issue this might have. So this is my power supply is connected to a special boot cable for Samsungs. Let me turn it off. I just know, I've done so many S10s, I know exactly the orientation of my cable. If you don't know the orientation, you probably shouldn't be doing this. All right, so I'm gonna push power, and I have 0 current draw before prompt to boot. So that means no short on a certain number of lines. Next, I'm gonna do prompt to boot. This is where essentially we get the housing. You know, the housing has a power button physically, right? So this power button actually has these contacts to the motherboard that send the signal to the board to say turn on. And those happen to be right here. So I'm gonna short them together. And look, no current draw. It's not reacting to my request to prompt to boot. That tells me either the battery connector is not making good contact, my cable's bad. Let me unplug it, plug it back in. Or there's an issue somewhere else. Look at that, no prompt to boot. So what we're gonna do is inspect the battery connector, and I could actually see it's not even attached. You can see this side is also moving. The battery connector is gone. So let's do this. Let me see if I could solder it back on, or we might have to just replace the connector altogether. Add some solder. Let me see if I get the solder to flow in there. We only need one pin, one side to attach, because they both kind of share the same connection. Look at that, I was able to get some solder to flow. Let me try the other side. This side needs a little more scratching. And the corrosion, I don't think people understand how destructive water damage is. I get tons of requests of people saying that they want me to fix their water damaged phone, that they have no data on there, they just want a working phone for long-term use. And I just can't do it. It's too crazy most of the time. Now, do I make exceptions? Sometimes. Just depends on the story. Yeah, for sure in this case, it is data only. Typically, if it's just external water damage, like to like a charging port or like the proximity flex or something, then I'll make an exception if the board looks clean. Or if like physically it's just in one tiny spot and the rest of the board is clean. And honestly, I probably should not admit that because I don't want people to like request water damage repairs now because they want to be the exception. I would say like really rare actually say yes. So please don't request it. All right, let me plug this in again. Maybe this time we'll get a reading. Yeah, see now we have a reading, and that reading tells us there's a short. This is unlike iPhones where you have a main short on a main power rail where it'll draw 2-3 amps before prompt to boot. Samsung's will limit it. So there's a short somewhere else on the circuit. So at the battery connector, there's only 39 milliamp draw. Typically 30 to 50 milliamp draw before prompt to boot will cause that. And then if I try to prompt to boot, it won't actually prompt. So that's expected when we have a main short. So let's go take a look, and I will show you on S10s, there's typically these two caps here that are part of the VPH power rail. If this reads as short, then we have a main short we need to track down. Yeah, look at the reading, 0.001, 0.001. A capacitor like these should not have connection to ground. So I'm using diode mode. I'm using red on ground and black on the cap. Only one side should read as ground. So we have a main short we got to track down. Now the question is, where is it? Those capacitors will read as short if there's a short on the whole circuit. So the thing about shorts is that you need to track it down via a different method. So basically a short cannot be measured. You cannot find it by measuring. You got to do it a different way, which I'll show you in a second. So first, let's expose a few more parts of the board. I'm really dreading this case because since the corrosion was so bad, I don't know if it's going to be fixable without a CPU swap, but I want to make a video on this one just to see, kind of prove to myself that I can figure it out. But we'll see. There's always the option of a CPU swap, although that's way more risky, and I always try to fix the motherboard first before going for the Hail Mary. All right, so inside this shield is the charging IC. Essentially, this is what connects the battery connection to the main power rail through this chip, and this is basically what limits the current from flowing backwards from the main power rail through the chip to the battery connector. So I always start here first to check for any obvious corrosion. It actually looks pretty clean. I'm going to assume that area is fine. I don't want to remove the shield unnecessarily, although I'm going to go to this side and remove this shield, because I would say a good 80 to 90% of these cases, there's water damage in here that we have to address. And the only way to get in the shield is hot air, and this is where a lot of techs get into trouble. They use way too much heat and overheat the CPU on the other side, and then they destroy the phone. And now a customer has to pay me much more for data recovery than was necessary. So here's a trick to safely remove this shield: is add flux to the solder joints that you can reach. And then I'm going to use special 138 low melt solder to tin these solder joints. This will essentially weaken the solder joint and allow me to desolder it much easier and safer. If you're not adding solder on here, then you have to use way more heat than necessary, which, the more heat you apply, the riskier situation it gets. So we're just going to go around the edges, fill this all in, thick layer of low melt solder. Now also, this low melt solder is risky in it of itself, because since the low melt, it stays liquid for a long time, so when you pop off the shield, this low melt solder might go flying into unknown places and cause secondary problems. So there's a lot that goes on with all this. All right, so I'm gonna use 380 Celsius with 50% air on my add-in hot air station to heat the shield. While it's heating, I'm gonna apply a little more solder here. See if I can kind of get in there and get in here too, because this is where I'm gonna try to lift the shield from. So there's gonna be a surprise under this. Either it's gonna be clean, like nothing happened, or it's gonna be corroded like crazy. By the way, I will link to all my tools from today's video in the video description below. If I leave out a tool, just let me know in the comments what tool you want to link to, and I will link it. Buying through those links does help support the channel, help support what we do here, and appreciate all you guys who are buying stuff through my links. Also, another thing, let me know down below in the comments, how do you approach water damage phones? Rice does not work. Just for all you non-tech people watching this, rice does does nothing to the motherboard to prevent any damage. It literally cannot suck water from inside of a motherboard, inside a phone that's sealed off. It doesn't suck moisture out of the air. Oh wow, look at that. Squeaky clean in here. Typically, one of these two ICs or both will be corroded. This is actually really clean. Awesome, that's good. Now there's another spot that gets corroded heavily. Typically, is this one here. So same thing, we're gonna add some flux. We're gonna add some low melt. Well, this one's way smaller. Probably can get away with no low melt. But I got some on there. This one, since there's no opening for me to grab it underneath, I'm gonna lift it up like an IC. I'm just gonna grab it and go up. And since it's such a small shield, it comes up pretty easy. You gotta get in real close, make sure it heat evenly. And here in a few seconds, it should lift. Here it goes. All right, well, now we have some corrosion. I don't think any amount of rice would solve this. But there's people out there who still believe this myth. All right, let me just clean off the surface of this. I see some gunk in between this chip here, and then in between these components. All right, so let's start off with just this. I think we cover or expose as much as we could. And just to prove that we still have a short, the cap is showing there's a short on both sides, which is not good. That means the next step is to get thermal camera. All right, so what we're gonna do is we're gonna inject voltage into this line, the VPH power, and see what heats up. So actually, all right, so this is the line that's shorted. These are the two caps I was measuring, and what we're gonna do is inject into this line, and anything in red could be the culprit because that's the shorted line. And because we have most of the corrosion here, I'm gonna start here and kind of go from there as far as where can the short be located. So let's start by injecting here and see if this area heats up. So look at my power supply. It says 4.2 volts, 0 amps, and I short these together, we get 3 amps. So that means my power supply is set to 3 amps maximum current draw, and the voltage is 4.2. So black probe on ground, red probe on the cap, and you can see there's 200 milliamp. If I touch this right, 191 current draw before prompt to boot, and let's see what's heating up. Is that this chip? All right, so I see this chip heating up. We'll come back to that, although I was looking for this area here. So that IC that's right there that I was under that shield is heating up. So that's typically a very common culprit. This IC here, so the corner is heating up, and here's the line that I was injecting to, and this chip was heating up. Let's check underneath to see if there's a corrosion. Really common issue on this model, and it's based on the corrosion we found when I removed the shield. I had a suspicion we're gonna focus on this area. So the chip is a MPB02. Honestly, I don't know what it does, but Mobile Centrics calls it the camera IC. But you can see the orientation dot. So I'm marking the board so I know if I replace it, or once I replace it, I know the orientation. I use 380. Also keep in mind, this IC is required for the phone to boot. It's a very common Samsung chip, and it's very, it's for sure required because it's very common to corrode. And I've tried booting phones without it. Alright, so now I gotta figure out how to lift this chip. I'm actually in a bad angle, but I can make it work. Alright, I give up. Let me rotate the board so I can get a better grip of this chip. Should come off in 3, 2, 1, 1. There you go. It's off. Actually, I don't see any corrosion. Now I wonder if there's a short somewhere past this chip, meaning main goes into the chip and then outside of the chip. So one of the signals that go through the chip, maybe one of those are shorted. So since I removed it, I'm gonna have to prep the pads. Now keep in mind, we don't have schematics for this model. At least I don't have them readily available. I think I should be able to find them, but for most cases we don't need them. Alright, so I prepped the pads by running my iron over all of them. Now we're cleaning up. Now we've blown away all the ISO and flux. Now we're gonna check for shorts on here. So I'll look at that. I remove the chip and the short's gone. So this is where we're always checking for shorts. Look at that, 218. But let's see, do we have a short somewhere on this board? Not there. No shorts that I can detect. So maybe it was a chip. There was a short past the chip. One of these would have been ground on both sides. I'm not seeing that. Although I'm either no short. Even the ugly looking cap. Yeah, so let's just go ahead and replace the chip to see if that solves it. Alright, so this is a donor board, unwater damaged, and the chip I need is under here. In my experience, this chip, the MBP02, I can't find new ones. All the ones I've purchased so far have been like used ones, and they're always kind of sketchy looking, so I don't trust them anymore. So I just end up grabbing from donors. So if anyone has Samsung S8, S9, S10 donor boards that they want to get rid of, that they don't need and want to donate to the channel, I sure would appreciate that, because these boards are not easy to find. So same thing, we're gonna heat the shield and desolder it. This is a donor board. Basically what that means is, let's say, dead motherboard or a locked motherboard that has no value other than the components. But in most cases, most donor boards really only have like 2-3 chips that are valuable. The rest are usually not faulty or never have to be replaced, or maybe like a connector or something. But this is what kind of sucks about buying donor boards. Some people overprice them because they think somehow they're much more valuable than they are. But for board level stuff, usually only a few chips that are really the ones that we can't buy. There's a lot of chips we can buy by themselves. So why buy a donor when we can just buy it brand new for like $2? But this is one of those that are hard to find. If someone has a good source for these, let me know. I'd be interested in that as well. Let's see, can I do a clean lift? This is a highly skilled technique, which is basically lifting a chip in a way where the solder balls are all even and I don't have to reball the chip. Only a few people have the skill to do a clean lift at a high success rate. And let's see. So I lifted it up perfectly. And do we have perfect solder balls? Let's see, I'm kind of holding it in midair. This actually looks like a good contender. But I see, you guys can see that odd shaped balls at the very left row. I don't think I could use this as a clean lift. All right, I'll just need more practice. Maybe 8 years of practice is not enough. Just need a little more. So we got a reball. I get a lot of people ask me, I want to learn data recovery, and the thing I always tell them is, well, you got to learn micro soldering repairs and master them, because you end up having to use all those skills from repairs a lot of times in one device. So, pulling ICs, reballing them, placing them back, running jumpers, diagnosing shorts, all kinds of things like DC power supply consumption. If you don't understand all those techniques and functions and troubleshooting steps, then you can't do data recovery. You gotta have the solder skills and the technique. Let's try with this. There's a S24 Ultra stencil. I'm sure I could find one of these that will fit. Nope. Yep. Let's see. So that looks like it's lined up. And if we shift over to the side, nothing's hidden. Above, no, and below. Oh man, see that? All right, all the holes are filled in. And I shift it up. There's another row. So yeah, this is not enough. I need an extra row of pads. How about this one? Nope, doesn't match. And I'm too lazy to dig up the correct stencil. I have it somewhere. And look at that one. That one lines up, although has extra holes. Well, at least have the holes we need. So we can reball this. And then, see, I have some solder paste on my spatula. This is 183 Celsius solder paste. And I just happen to have just the right amount. This paste has been dried out by sitting on my bench for a day or two, which makes the paste really easy to reball with. So you can see the texture is like a matte color, it's not glossy. You might wipe it down. You can see all the solder paste filled in all those holes. And then we're going to use 3 35 to create some shiny solder balls. If you made it this far into the video, make sure you comment shiny solder balls, and also get yourself a shirt that says shiny solder balls. I'll link to my merch site in my video description. And there you go. Those are the shiny solder balls that we need, that are even, so that we can properly install this without any problems. Right now this thing is stuck to a stencil. There's going to be some extra solder on the side. Oops. But we just care about the chip. This excess solder over here can go to the trash. Although I do need to clean the stencil. So whenever you do this and you have a bunch of solder balls left behind, just use your iron to kind of brush over it, and your iron will suck it all up, and now you can just clean it like normal. Whereas I don't even know which one I used. So we're not done with the reball process. Actually, there's like some excess solder here on the side. Alright, so I'm going to reflow as is. There you go. And then we're going to, while it's hot, add a little bit of flux. It's not hot enough. Alright, reflow with some flux in there. Alright, solder balls are now shiny. And let's go ahead and install this back onto the customer's board. Now I'm just going to do it here on the work mat. I'm going to put the thing on the board holder. Just put some solder flux. A little bit. We have some on the chip already. Also, the dot goes to that chicken scratch I made over there. And then we gotta line it up. I'm gonna use some low temp and low airflow to install this. The chip is small, so it doesn't need that much. And I reballed it with lower temp solder than the factory. So this should install pretty easy. Now I may have put too much flux, but let's see. It looks like it just snapped into place. I'm gonna bump it. Yeah, it's there. Now we wait. I'm gonna hit it with the fan a little bit. This little fan here. Give it at least 5-10 seconds before I touch it. We want the solder to solidify, and I don't want to mess up the installation. Alright, should be good. Doesn't feel hot. Alright, so here's the donor. I'm going to put that away. Now let's test this out with the power supply again. So remember, before we had 39. Alright, so let's start with off, in the off condition. And then plug it in. Huh, we got higher. 90 something. Let's see. That's weird. We went from, usually when you clear shorts, you should expect the number to drop. Although, let's see. Where is this 90 milliamps coming from? Oh, look at that one I see. I know for sure that one's not needed. I pulled it recently. Yeah, see, I unplugged it and it went away. That's this black one right here. Yeah, you can see some corrosion there. I can see why this could be a problem. If we check on ZXW, you'll see that this does have VPH power, a path to VPH power. So let's just go ahead and remove this chip. I don't know what it does either. If someone knows in the comments, let me know. I would suspect maybe a gyro, like rotation related. Kind of looks like the iPhone one, in my opinion. Alright, let's spread the flux and heat this up. So I'm not trying to do a clean lift on this one. So what I'm doing is grabbing the chip and slightly raising the board up. This will make the chip disconnect. And oh yeah, look at that. I don't know if you guys can see that crud. Oh, that doesn't make it visible either. There's some black, nasty stuff here. Trying to get in focus. Here, so see this? This is all water damage, corrosion. And as you noticed, there was corrosion under this IC that was not that obvious. That also is the reason why water damage repairs are not feasible, because you're gonna find there's gonna be a bunch of chips like this that have corrosion underneath. Unless you plan on lifting every single chip, checking underneath to see if there's any corrosion, then yeah, you're gonna go out of business trying to repair stuff like this. I even have repair shops who should know water damage is very destructive, asking me to repair water damaged phones for them. And it's like, no, data only. You see all that crud kind of floating away? That is probably your 90 milliamp draw right here. And just scrubbing it did not clear it out. I had to like literally poke it with my blade. Look at that. Now there's no bridging between all those pads. The question is, are we now cleared with the short? And look at that, no short. So no short means we don't need a thermal camera. Let me just make sure we're plugged in. We'll know we're plugged in if I can prompt to boot and get a normal boot consumption here. All right, so like I mentioned, we short these pins together. So I usually use my metal tweezers and 3, 2, 1. Look at that, we get current. Boot up consumption looks normal. That looks like a booting phone. So see how it slowly kind of fluctuates and works its way up? I mean, it does come back down and come back up. That all looks normal. So let's throw this into the housing so we can verify if it's actually booting. Just the boot consumption itself is a good indicator that the phone is fixed. Now for this model, in order for it to charge, we do need the wireless charging coil. There's a temperature sensor on here that needs to be making contact with the board. So let's put this in there. And I always put 2 screws, one for the temperature sensor contacts. Make sure it clicks in place. And then one for the power button. So both are like contact based, like pressure based. The board is physically pressing on through some contacts. And then since we know the boot consumption looks normal, we should expect the USB charging consumption to be normal too. Plug it in, USB wakes up, we get vibration, charging logo, and this should boot up. Look, we got 9 volts charging at 1.5 amps. This looks like, oh, look at that, 74%. Let's go ahead and boot this phone up, pushing the power button, prompt to boot. Samsung logo. So let's go ahead and let this boot up and make sure we can get into the phone. Look at that. We have touch. All right. Yeah, look at that. It's booting up. So this is going to be a successful data recovery. I'm really excited. The water damage looks so bad. I was not having good hope for this, but it turned out it's pretty straightforward. There was 2 chips and the battery connector was corroded. That's all we needed to fix in this specific case. In your specific case, it might be different. Some might be harder, some might be easier, but we do charge a flat rate for the standard data recovery service. If this was really bad and we needed to do a CPU swap, it would have been way more. But I'm happy this worked out. So if you guys enjoyed this video, make sure you guys are liking, commenting, sharing this video. Get yourself one of these t-shirts to support the channel. And like I said, I have all my tools, the USB meter, the DC power supply, thermal camera. That's all linked down below. So thanks everyone for watching. Make sure you guys check out this video right here where I cover another water damage repair. So see you guys in the next video.